This video is explaining how to find the area between a curve and the x-axis when some of the area is below the axis and some of the area is above. So finding the area means finding the integral, and in this case, with this example, we've got a curve x cubed minus 6x squared plus 11x minus 6. So we're going to find the integral, and I want to find the area between x equals 0 and x equals 2 of that curve. So that's x cubed minus 6x squared plus 11x minus 6, and that's all with respect to x. We put equal dx at the end. And as you can see from the graph, some of that area is here, which is below the x-axis, and some of the area is here, which is above the x-axis. The area that's below the x-axis is going to be negative, and the area that's above the x-axis is going to be positive when we calculate the integral. That means, of course, that if we were to simply work out this integral as it stands with the two limits, 0 and 2, then the negative bit plus the positive bit would cancel each other out to a certain extent, and you'd end up with an incorrect total area. So in order to be able to work out the correct total area, we need to split the integral into two parts. We need to integrate between 0 and 1 to start off with, the function with respect to x, and then we also need to integrate between 1 and 2, the function with respect to x. Now the tricky bit here is what to put as our symbol, because we know that this area is going to be negative and this area is going to be positive, and adding them together is not correct. What we have to do first is make this bit into the actual absolute value and not the negative bit. So putting this plus isn't strictly correct. So I'm going to move on to a clean page, and I'm going to do the two integrations separately and then deal with the signs at the end. So here we go. We want to find the integral, first of all, between 0 and 1 of x cubed minus 6x squared plus 11x minus 6. And it's all with respect to x, so we put dx. So first of all, to integrate each term, and then we're going to evaluate between the limits. So we put big square brackets to show that we're going to evaluate. The integral of x cubed is x to the 4 over 4. Add on 1 to the power, divide by the new power. The integral of minus 6x squared is 2x cubed. Adding on 1 to the power makes it 3. Dividing by the new power, 6 divided by 3 is 2. So that's a simplified version. Plus 11x squared over 2. I can't simplify that in the same way, so I'm going to leave it as a fraction. Minus 6x. Close our big square brackets and put the limits 0 and 1. And then we're going to insert the top limit first, this limit here, 1, and we're going to make x equal to 1 in each term. So that gives us 1 to the 4 over 4 minus 2 times 1 cubed plus 11 times 1 squared over 2 minus 6 times 1. That's putting in 1. And then if we substitute 0 in to each of the terms, and we're going to subtract that away. But if we put 0 in here, because each term contains an x, the answer is going to be 0. So that makes our life a little bit easier. Now, a quarter to the power 4, so 1 to the 4 over 4 is a quarter, minus 2 times 1 cubed is just 2, plus 11 over 2 minus 6. Not a pretty thing to do, but with a bit of work we discover that that's equal to minus 9 over 4. Therefore, the area between 0 and 1 is equal to 9 over 4 units squared. Remember, the minus simply tells us that the area is beneath the x-axis. Let's notate that in. So the area is below the x-axis. And that's all it tells us. So we can ignore it when we're talking about area. Now we're going to do exactly the same thing again, but we're going to integrate between 1 and 2. By looking at the graph, we saw that this function between 1 and 2 lies above the x-axis. And so we should expect to get a positive answer. Let's see what happens. So the same thing again, we put our square brackets, we integrate, giving us the same function as before. So we've done half the work now. Although we're going to have to plug in some more numbers, we've done a lot of the work we need before we get to it. So we're going to, as before, start by plugging in the top limit as our x value. That gives us 2 to the 4 over 4 minus 2 times 2 to the 3 plus 11 times 2 squared over 2 minus 6 times 2. That's from plugging in the top limit. Now we're going to plug in the bottom limit, which is 1. But wait a moment, we did that before. We did that in the previous slide when we were plugging it in and working out the limits between 0 and 1. And when we did that, if you remember, we got minus 9 over 4 as our answer. So if you remember, we're taking away minus 9 over 4 because we're taking away what we get when we plug 1 in. So let's work this through. 2 to the 4 is 16, divided by 4 is 4, minus 2 times 2 to the 3 is 8, 2 times 8 is 16, plus 2 to the 2 is 4, divided by 2 is 2, so 11 times 2, 22, minus 12. Let's deal with this minus minus at this point. Minus 9 over 4 is plus 9 over 4. If we work through the arithmetic here, 4 minus 16 gives us minus 12, and 22 minus 12 gives us 10. So this total thing here is equal to minus 2. So minus 2 plus 9 over 4, and that's 1/4. So the area between 0 and 2 for this function is 1/4. If you remember the graph at the beginning, that area was really much smaller than the other part, and so that makes sense. So let's put all of that together in our final slide. So if you remember, we're trying to find the integral between 0 and 2 of x cubed minus 6x squared plus 11x minus 6, all with respect to x. And we had to split that up into 2 bits between 0 and 1, our function, and between 1 and 2, our function, because the bit between 0 and 1 lies below the x-axis, between 1 and 2 lies above the x-axis. Therefore, we had to find the absolute value of the negative bit, and that was 9 over 4. And when we found the area of the bit above the axis, that was 1/4. So in total we've got 10/4, or 2.5 units squared as the total area. And that's our final answer.